We've been focusing on finding the equation of the line using the slope or angle and a position, and specifically the y-intercept position. But again, we can show, as long as we show the slope and some position, we really are describing a unique line. So we're going to come up with a different way to show the equation of this line. And we're still going to use the same properties. We're still going to use slope and a point. But instead of using the slope and the y-intercept, we're going to use any point on the line. Because if I know the angle and I know one point on the line, that's going to be a unique line. It's going to be different from this line, which has a point maybe over here. So as long as I have the slope and any point on the line, I could really describe the equation of the line. In fact, this is a much easier way to describe the line because we don't have to rely on a specific point, the y-intercept. We can use any point. In this case, we'll label that point general point x1, y1. The nice thing about the y-intercept is it tells us initial value, but it's a specific point. The point-slope form is much more efficient because we don't have to rely on the specific point b, the y-intercept. We can use any point on that line. So the way it works is this. So the equation, the point-slope form has this form. So it has the slope, it shows the slope here, and it has the coordinate here and here. Here's my x coordinate, here's my y coordinate. This x and this y are my x and y variables for the relationship. Okay, so they're different. Now, I just want to show, let's actually do one example and then I'll show you why this works. Okay, so let's first do this example. I have a point at 1 over 2 up. I have another point at 7 over, so 4, 5, 6, 7, 1, 2, 3, 4 down. Okay, so there's my line. And it looks like the y-intercept is maybe some around 3 or something like that. Okay, I'm going to use it. Those lines aren't looking very good, so I'm going to use a little help here. Okay, and so there's my line. It looks like my y-intercept's at 3. So let's calculate the slope. Go ahead and calculate the slope. We still need the slope, so my slope is going to be -4 minus 2. So my slope is my rise is -6. My run is going to be 7 minus 1, or +6. So my slope ratio works out to be -6 over +6, or -1. Okay, now the nice thing is, before I had to plug in x and y to calculate the y-intercept. Now I don't need to calculate anything. I can just plug in x and y. Because my equation is going to look like this. Y minus, okay, my slope. In this case, it's going to be -1 is my slope. And then it's going to be x minus x1. And as long as this x1 and y1 is a coordinate pair on this graph, it doesn't matter what we use, because any point on that line with the slope will describe this specific line. So I'm going to just use one of these 2 points because it's already given to me. Now it doesn't matter which one I plug in, just as long as I make sure my x's and y's are in the right spot. There's my y, there's my x. So I'm just going to plug those numbers in. Y is 2, x is 1. I'm done. I don't need to calculate the y-intercept here. I can see that my y-intercept is 3, but this is my equation of my line. Now, I personally like to write it so that it's y equals, so that's a function. So I'm going to write it as my y equals function, x minus 1, and I'm going to add the 2 to this side. Okay, so it's going to be +2. And so when you do it this way, you just have to remember that the x is going to be backwards, it's going to be minus, and the y is going to be, if it's +2, it shows up as +2 on this side. Okay, and there's my equation in function form. And so if I really wanted calculate the y-intercept, and sometimes it is useful to calculate the y-intercept, all I have to do is expand out the brackets, and I end up with negative x plus 1 plus 2, so that gives me plus 3. And sure enough, that's my y-intercept. But I don't need to do this step here. I can just leave it like this, and this is a much more efficient and convenient form of the equation of the line. And when we get to calculus, this is a form we always use. The only benefit of this is that it tells us the initial value. Okay, but it doesn't do anything more than what we knew before. We needed a slope and a position. We have a slope here, and the position was 1, 2. And that's good enough, and that gives us the equation of the line. So it is a much more efficient way of calculating the equation of the line.